in this project, I created an API endpoint with an AWS Lambda function where you can provide a URL and you will get back a QR code for this specific URL. So you can call this endpoint, for example, like so. We have our function URL, and then you provide the parameter inside the URL, which represents your string. So your URL that you want to convert into a QR code. And you will get back a PNG image of your QR code. I will now walk through the technical details, and in the end, we will do a live demo and see if it works. So I deployed an AWS function, Lambda function, with node 22. And I used TypeScript for the function code itself, and I deployed the infrastructure using Terraform, because I'm a big fan of Terraform lately. Yeah. So let's look at Terraform code first. We create a AWS Lambda function and give it the input. The input is a zip file. I provide the code as a zip file. And then it's also hashed. So when you reapply a new version, but you don't change anything in the function code, it will not update. No. And then we also need a URL. So this is the AWS Lambda function URL. Then we also take it out as an output in the end to know where the function is actually deployed on. So let's do the Terraform apply together quickly. First of all, we need to package the code. Then we can go ahead and apply our Terraform. Okay, here we go. So we got back the URL here. Let me copy this one. And then go ahead. Okay, so the URL stayed the same, so that's great. So we can run our first test here. I'll just go ahead and send a request to our API that we just created. So I will do it with curl, and then we send the URL github.com to our API endpoint, and then let's name it QR code GitHub. Okay, so an interesting thing is always the wake up time. I'm not sure if probably the function was awake already now. So the container was already started because it just took 2 seconds. I'm not sure if it's always that quick. So far from my testing, it was always very quick. So I'm surprised, but maybe if I leave it for a few days, it will fall asleep deeper. I'm not sure. But here we got back to QR code, which leads to github.com now. Then this brings us also to our function code, which we can go into here quickly. So you can provide the URL to our endpoint in 2 different ways. One is to provide it simply as a parameter, as we did in the example, or you can also include it in the body if you decide to send a post request. If you don't provide a URL, of course, we will notify. I will notify you with a 400 error. And then to generate the QR code, I use this library called QRCode, JavaScript library. And what this gives back is a string starting with some meta information, so metadata. And this was one of the most important learnings apart from AWS Lambda learnings, that here we get back metadata first. So it starts with like data and then image PNG and then base64 comma. And we only want to extract everything which is after the comma, which is the base64 encoded image data. So the image is usually a binary, but it's encoded as base64. And yeah, we just get that with splitting by the comma and then taking the latter part that comes out of it. And yeah, if everything goes well, we can send it back. And this was also important learning, that in the HTTP response, we can send we can set this flag here is base64 encoded to true. So when you request this image in the browser, or as we just did here in the from curl, whatever, you will know, or the system will know, okay, what is coming back is actually base64 encoded binary information that I should save as a PNG. And that's why it's here ready as a PNG. We don't need to do any decoding here. And then if anything goes wrong, we provide a 500 error, of course. Okay, so then I thought to myself, why not take this to the next level and build some caching around it? And with that, I will also make a quick live demo for that. So I have to switch to another branch quickly, because I did this on another branch, and then we can deploy it live together. So let's look at the Terraform first again, once more. Here, what's changed is that now we have a DynamoDB. And the cool thing with those NoSQL cloud databases is that you can also just pay per request. So the whole project stays very, very cheap, which is cool. And we save for URL as the hash key. And then this one here is also required, so we need to just provide the table name to the function. And yeah, this is basically it. Let's deploy this infrastructure once more so that our function code gets changed and we add this whole caching layer in real time. For this, we need to build it again. Like so. Okay, the build is done. Then let's start with the zip archive. Okay, then let's run the Terraform apply in the meanwhile. And meanwhile, we can talk about the code quickly. So one interesting thing that I learned, this addition to the project here. That looks fine. Okay. So one thing I learned with this addition to the project is that we can initialize some constants outside of the actual function handler in order for them not to be reinitialized on every function call. So basically, if the container gets maintained, stays alive during different calls, those variables will stay in the memory of the container or of the VM that our function is run on. If we did that inside the function, if the container stays alive, which in AWS, as I researched, is usually between 5 to 7 minutes of inactivity. If you get another request within 5 to 7 minutes, it would reinitialize those variables, which cost more compute or more compute time. So yeah, that would be not as efficient as we could make it. So I had those outside. And the rest is similar, although we check the database first. So when we get the call, we have the URL. Okay, the user wants to get the QR code for this URL. And then we will check in the database, do we have any entry for this key? Which we do here, provide the key and send it off to the database, get back the result. And then if we get it, we log. I added some logging here, which we can look at later. Then we have the base64 string of the image. And if not, okay, there could be an error, yes, of course. And either way, in case of an error or we don't get anything back, we will generate the QR code freshly. So ideally, this whole block here, this whole if block, would be skipped if we have cache available, but if we have a cache miss, we would regenerate it. And for that, just do the same as we saw before, and then also try and save it to the database, so we have it cached for the next time. So we prioritize the URL as the key, and the base64 image as the value. And also a little timestamp, because why not? Yeah. And then we return the image, and in the error case, 500 error. Okay, so from what I saw, the URL stayed the same, and we can test this again. So let's get our now let's make it beautiful. So let's see. I will do this as GitHub 2, and now we will have a look at the time which is spent. So this took roughly 3 seconds. We can look at the details in the logging later on. And I'll do another one. And here you can already notice it's a lot faster. Let's do it once more. Okay. And check quickly the images that we got. So we got the QR codes, which is great. And now the interesting part really lies in the logs, which was also a great possibility for me to get in touch with AWS CloudWatch to look at the logs of our QRCode-Generator function. And if you go into monitor, look at the metrics, I learned that you need to go here to CloudWatch logs. In here is where the logs get aggregated. Okay, so let's see with the timestamp. This should be the newest one. Okay, so let's see. First of all, we got a cache miss. The QR code was generated manually, basically. Yeah, and then the request ended. And I really like how this is logged here. This is amazing. You see, it took roughly 2.1 seconds of compute time, and we got billed, or 2.5 seconds even. Yeah. And then we send it once more, and here we see we have a cache hit. So second time it found it in the cache. And what's really cool to see here is that the duration got down to 200 milliseconds. So that's just 10% of what we used before. And then, of course, here it was even a bit faster. But yeah, this is, I mean, this one is a bit a very theoretical case that someone would send the exact same URL within such a short time. But I think we can take this one here as a rough estimation value and compare it to our first request here, which would be a 10x improvement in the execution time that we saved because of this caching mechanism. All right, this is it. Thank you so much for your attention, and have a great day.